Alright, so today we're going to be taking a look at the boundary engineering inspection process. What I have in front of me is actually a Coyote oil pump for the Ford Mustang 5 liters. So this one's for the Mustang explicitly. It's a little bit larger than your F-150 gear set. But what I'm going to be doing is showing you guys how we go through and verify that this is a good gear set. So first off, we'll go ahead and I'll take them out real quick. So I have a Coyote Mustang oil pump housing right here in front of me. Now this one's actually getting worn a little bit. It's seen about 500 gears, so you'll have to apologize for the scratching and everything. What we want to do is, first off, we're going to do a basic inspection of the gear. So we kind of take a look at it, make sure that there's no burrs or anything like that on the profile. We look on both sides. We got our boundary logo there. All looks pretty good. And same thing on this side. So we're looking for just tooling marks, anything that's kind of out of control. So didn't really see anything. Everything looks pretty good. So whenever you're assembling this at home, you can also use this. What I always tell people is that the nicer you are to it, the easier it is to actually make it go in. If you try to use force, you'll get it jammed. But if you just take and very gently kind of rock the gear, if you feel any resistance, it'll go right into place. So you're looking for that click where it's all the way seated. And then we're going to do the same thing for the inner gear. And there are no up or down or lefts or rights. The gears can go literally any side. So you can have the boundary logo on the bottom or on the top, it doesn't matter. But now that we've got it here, there's 4 critical clearances that you want to take a look at whenever you've got the gear set in the housing. So I have this Mitutoyo straight edge. This thing's supposed to be straight within like 50 millionths. You don't need anything close to that good. But what you want to do is you want to place the straight edge over the top of the housing, and then you want to rotate it, okay? So what you're looking for is any place where the gear would snag on the straight edge. You should never have contact between the plate and the gear. And before you do this, I'm going to take the gears out one more time just to show you. So whenever you're assembling your gear set, you want to make sure that this is all clean, right? So there's nothing that's down in here that's going to cause the gear to set up artificially off of that face. So it's lying in there completely flat. I'm going to do the reassembly. Okay. So now I have in front of me my trusty Mitutoyo. I'm a Mitutoyo guy, if you couldn't tell. Feeler gauge set. These guys have seen a little bit, but they still work well. And what we're going to do is we're going to measure that distance. So I just spun the gears. I'll do this. See, there's no contact. You're going to make sure you get the straight edge all the way across. And just so you guys know, this pocket itself is usually canted about 5/10 thousandths of an inch from one side to the other. So if you mount this housing completely flat into like a CMM against this face, the bottom of the pocket will actually have a slant to it. So if you measure on one side and you get something you measure on another side, there are going to be one of two things happening. Either the gears aren't completely flat or the housing isn't completely flat. But what's important is that these faces are within a tolerance range of the very top of the housing, because that's what's going to give you your oil seal. So we take and we look at these feelers. So that's a 15 thousandths that just went, or 15 tenths that just went under. All right, here's a 20. Okay, 25. Okay, now you see how when I tried to put the 25 under, it's gripping. So that means that the measurement is somewhere between the 2 thousandths and 25 tenths size. So I generally would mark this as 25 tenths. And then what you can do to kind of verify and see where you're at on flatness is to do the same thing on the other side. So I'm going to take and see if we can get it to go under. So it just goes under with a 15. So we've got 25 tenths on this side and about 15 over here. So the gear is roughly flat within 1,000th in this housing. And then you want to do the same thing on the inner. So we're going to take this and put it under. Okay, so the 20 is gripping a little bit, and then the 25 again is gripping pretty tight. So we're going to do the same thing over here. Okay, so you see that it's in between the 15 and the 20. So I would mark the inner as 2010s or 2000s, and then the outer as 25 10,000s. So that's that measurement. Now, that measurement can vary. So these pumps can be set up to have different characteristics based off of the clearances that you have, okay? So you can optimize them for either efficiency, for total pumping capacity, or for durability. And what we generally ship out is somewhere that's kind of a mix of those different characteristics. So you'll typically see about 4 thousandths clearance on that width. You'll see either one, 4, 5, 3, we go up to 7, and then you can go all the way down to 1,000. So it's somewhere in that range. But you'll see that on the width. And then the next measurement that I'm going to take is what we call the tip-to-tip clearance, which is where you take and you seat the gear all the way against the stops here. And then we see, you pull it just a little bit off center, and then you see what size will fit while these gears are rotating against each other, right? So that was 3. 4, it still rotates. Okay, and 5 is gripping, right? And the same clearance range applies here. So what you want to see, you basically won't be able to get a gear to spin very well under about 1,000th, and that's very, very tight. And then the maximum clearance that you'd want to see there is 5, 6, 7, somewhere in that area. OEM manuals generally provide for a little bit larger clearance than that, but that's all that I would recommend. So that's another measurement that goes down on that sheet. And then we have one final measurement that we call the body measurement, which is just from this outer rotor up to the actual housing. So we're going to go and measure that. Okay, so try to fit a 7, doesn't work. 6 doesn't work. 5. Okay, so 5 kind of makes it in there. Yeah, I'd say it's a 5. Okay, so 5 thousandths. Now on this OD, this is the loosest clearance of all of them. And it makes a pretty good impact on the durability of the gear set. So this has a very wide range. You can go from anywhere from about 1,000th, like the rest of them, all the way up to what the manual says about 8 thousandths. So in truth, you can go beyond that. It's not going to impact the pumping performance. One little final thing on these is how these gears actually work. They're a little bit of a mystery to a lot of people, and for good reason. So I'm going to take this middle gear out of here just to kind of show you. So this over here would be what would be the called the induction side, right? And then this over here would be the high pressure side. So whenever the fluid gets sucked up into this inner gear basically it's held here by the crank, right? So as this spins, what it's doing is it's creating volume, right? So this is opening up and this is sealed by this tooth right here. So as this thing spins around, it's going to open up, breathe in just like a set of lungs, and then compress out onto this high pressure side. And then before it gets over here, it's going to pretty well completely empty. You'll see this port down here. It's going to pretty well completely empty by the time that it gets all the way over, right? So we have it opening up over here and then pinching the fluid as it comes across. And then by the time it gets down here, the lobe is completely empty. So that's the basic sciences behind it, behind how the thing breathes. But at any rate, I hope this kind of educates you guys on how we do our process here and what would be a good rule of thumb for you checking in your own housings. We do check every single one that comes through, And the reason that you'd want to check on your own is particularly where you're using a used housing. If you see something like an extremely high reading on any of these clearances, you know that your housing is worn, or that it at least needs further investigation to understand it. So I guess that's it for us. Thanks for joining in, and hope this was helpful to you.
All right, thanks.